Alrighty, so we're in lesson 99 to 100. So this is lesson 99. And what we're learning is about the absolute value. When you have an absolute value in an inequality, how do you handle that? What do you do with that? So let's look at that. So we've got, let me get my pen here. We've got negative absolute value of x plus 1 is less than a negative 3, and the domain is reals. Okay. So first, it's the same thing that we normally do. We want to get x by itself. So we do that part first. I'm going to subtract 1 from both sides. That leaves me negative absolute value of x is less than negative 4. We know we can't have a negative on x, so we're going to multiply everything by negative 1 to get rid of that, same as we normally would. So the opposite of the negative absolute value of x is just the absolute value of x. When we multiply by negative 1, then the sign flips, and then this becomes a positive 4. All right, so now that we have it where we can actually do something with it, we have to allow for the fact that what the x value inside of the absolute value brackets could be negative and it could be positive. So let's do the negative first. Negative x, you take it out of the bracket, is greater than 4. We know we can't have a negative, so again, we're going to multiply by negative 1. So that gives us x, flips the sign again, and makes that a negative 4. If this is the negative value of the absolute of x. If it were the positive, it'd be exactly the way it looks. You just say x is greater than 4. So you are going to graph this. First, we're going to look at it and decide how we're going to graph it. The domain is reals, so that's a straight line. If x is less than a negative 4, we would come over here and we would circle the negative 4 and move to the left, so that would be less than. If x is greater than a positive 4, we would come over here and circle the positive 4 and then go to the side that is greater. So that's how you'd graph that. Those are the numbers that would make this a true statement. That's all we're doing. Whenever we get to the end here, you allow for the negative, and then you allow for the positive value of x inside of the absolute value brackets. That's all we're doing. Let's do the next one. All right, so we'll do the same thing with this one. We have the negative absolute value of x plus 5 is greater than 0, and our domain is integers. So integers is that little funny Z looking dude right there. All right, so we do the same thing we've been doing. We're going to subtract 5 from both sides. Negative absolute value of x is greater than negative 5. Multiply everything by negative 1. Positive absolute value of x, flip the sign, positive 5. We allow for the negative. So it's going to be negative x is less than 5. Multiply everything by negative 1. To flip it, x is greater than negative 5. Now we allow for the positive value of x, which would just be what it is, just like that. So when we graph that, we're going to graph x is greater than negative 5. X is less than negative 5. So what I see by looking at these two is that I have a conjunction. If I put x in the middle, x is less than 5, right? And then x is greater than negative 5 is the same thing as negative 5 is less than x, right? The open side is still to the x. The open side is still to the x. But that gives us a conjunction that we can graph relatively easily. We would just circle the negative 5, circle the positive 5, and draw. Actually, no, we would not do that, would we? We would not, because the domain is integers. So we still have this conjunction, but because the domain is integers, we're just going to put a dot on all the integers that would be between negative 5 and positive 5. That's how you would graph that. Sorry, I almost messed up for a second. I get on a roll sometimes and I don't pay attention to the details. And we know that in math, the details matter. This would be the correct answer. Let's look at the next one. These are fairly quick. They don't take a lot of time if you understand what you're doing. So the negative absolute value of x plus 5 is not less than or equal to 3, and the domain is reals. And this is, if you're wondering, this is the symbol for reals. It's like a fancy double-lined R of some kind. Don't worry about it. It's faster to write it that way. So the first thing we have to do when we see a negated inequality is write it for what it is, not what it isn't. So we would rewrite that. And if it's not less than and it's not equal, then greater than is the only other sign available. Now we can solve for x. So minus 5 on both sides. Negative absolute value of x is greater than a negative 2. Get rid of the negative absolute value of x. Now we have absolute value of x less than positive 2. The negative value here would be negative x less than 2. Multiply everything by negative 1. X is greater than negative 2. The positive value of that would be x is less than 2. So let's look and see if we can do, yes, we can do a conjunction with this because we have x is less than 2 and then x is greater than negative 2. Usually, if you have opposite signs like this, where x is less than, x is greater than, you can create a conjunction. So negative 2 is less than x, which is less than 2. X is still greater than negative 2, which is what we have here. We just flipped it around and kept the larger opening to the x, just like that. So now we can graph that in the domain of reals. So we're going to circle the negative 2 and circle the positive 2 because this is reals. We'll draw a line between the two. There's no equal sign, so we don't have to worry about filling in the circle. Next problem. All right, another absolute value this time. We have negative absolute value of x plus 3, and it is not less than 2, and the domain is integers, and the symbol for integers is a fancy double-line Z. And that's another lesson coming up. If we haven't gotten there yet, then that's what that means. So again, don't write it for what it's not, write it for what it is. So it's going to be negative absolute value of x plus 3. And if it's not less than, then it is greater than or equal to. Those are the other symbols. We combine them together. All right, so now we subtract 3 from both sides. Negative absolute value of x is greater than or equal to negative 1. Multiply by negative 1 to get rid of the negative sign. Absolute value of x flips the sign, positive 1, right? We're going to allow for the negative first because it takes the most work. So negative x less than equal to positive 1. Multiply by negative 1, x greater than equal to negative 1. Positive is just the way it's written. X is less than or equal to positive 1. So again, we have the ability to write a conjunction because they're facing different sides. So x is less than or equal to 1. And we have negative 1 is less than or equal to x. So less than or equal to negative 1 is less than or equal to x, which is less than or equal to 1. It's integers, and negative 1 and positive 1 both have the equal sign on them. So we can dot the negative 1, the 0, and the positive 1. And that is our solution set for this problem. That's it. That's all we can do. All right, next problem. We've got another one like that. You can kind of see, when you do them quickly, you can kind of see how they're all the same. They're all the same process. We are writing it, making sure that this is not negated. Looking at the domain here is going to be integers again. And you can just make that whatever you want, but it's integers. All right, so it's not negated, so we are just going to add 2 to both sides. Negative absolute value of x less than or equal to negative 3. Get rid of the negative sign. Absolute value of x greater than or equal to positive 3. Negative value of what's in the absolute value brackets is negative x greater than or equal to 3. Get rid of negative x. That's going to be x less than or equal to 3. The positive value in the absolute value brackets will be x greater than or equal to 3. Oh, this should be negative 3, sorry. All right, so these are opposites, but they are a disjunction because the greater side is not less than. So we have a disjunction. So x is greater than or equal to 3, and that's integers. So it's equal to 3, so we can include that. So it's going to go like this. You're going to graph all of that, right? And x is less than or equal to negative 3, so we include the 3, and we go to the left for the less than. And we're using the dots because it is integers. All right, next problem. And that was all for lesson 99. We did that in like 11 minutes. Not terrible. All right, let's look at lesson 100. What is lesson 100? Okay, so we're going to complete the square to aid in graphing. Completing the square tells us the points that we need to have in order to graph a parabola. That's what this is all about. And if you need more information on that, you can go and watch the video. But basically what you're going to do is you're going to complete the square in a certain way, and it's in your book what those steps are. It is written in your workbook. So the y-intercept, we don't have to do any math whatsoever. We can look at the original equation and we see this plus 3 right here. That is the y-intercept point. So our very first point is going to be 0, 3. That's our first point. Okay, that's all we can do before we do any math. Now we have to actually do the completing of the square. How are we going to complete the square when we don't have it set equal to 0? It is tricky. So I'm going to show you how that works. So we can't factor this, right? So we have to find another method, and that method is completing the square. We create a synthetic number to do that, but we can't move plus 3 over here. It's just not going to work well. So what we're going to do is we are going to create a space using parentheses and put this on the outside. So y is equal to, this is x squared minus 2x. We're going to leave a little space and put our parentheses, and we're going to move this plus 3. We're going to treat it like it is on the other side when it's just outside of the bracket, right? It's outside the parentheses. We're going to do the same thing we normally would when completing the square. We're going to take this negative 2, divide it by 2. That equals negative 1. And we're going to square that. That gives us a positive 1. And we're going to add that to both sections. However, if we add this here, we add 1 here, that's changing the value. We don't want to change the value. What we want to do is take into account that it's on the same side of the equation. So we're going to add 1, we're going to take 1 away. And that keeps the equation true because it's balanced, right? Plus 1 minus 1 means we don't add anything. They're opposites, they're 0. So we're adding nothing to the actual equation. All right, but that makes it to where we can factor this. So y is equal to, and we factor it exactly the way we do when completing the square. We look at this number that we squared and we put that with x. X minus 1 squared. Now we combine these numbers here. There's going to be a positive 2. That is all you need to do. This tells us everything else that we need. So the axis of symmetry is that line that is through the center of the parabola. If you don't know what the parabola is, it is that All right, here's your graph. The parabola is that U, right? It's that U-shape thing that we graph. That's the parabola, right? All right, so let me show you. Let me get a little bit of graph paper up here. Let me see if I can move this over. Ooh, that's way out of bounds. Let me put that right there and shift this over. There we go. Now I can see all my tools. Okay, so let me turn this into, there we go, graph paper. So I'm going to draw my, that's really a terrible line. Let's see if I can do better. I'm going to draw my graph here. Okay, that's much better. And I'm going to draw it here as well. Okay. All right, so we've already said that our very first point was 0, 3. So I'm going to come here to 1, 2, 3. That is the y-intercept. That is where it's crossing the y-axis, the parabola is. Our axis of symmetry, we're going to take this number right here, and we are going to multiply it times -1. And that is going to equal our axis of symmetry. So, times -1, -1 times -1, that's going to be a +1. So, +1 is our axis of symmetry. So, x is equal to 1. All right, the value of the axis of symmetry is your x value in the vertex. So we're just going to put 1. That's the same number that we just typed for our axis of symmetry. And our vertex, the y value, is going to be this digit here that's sticking out on the end. So 2. So 1, 2. That is going to be our vertex of our parabola. So that's what this number is. It is the y value of the vertex. And the axis of symmetry is the x value of the vertex. And the vertex is just the place where it hits bottom and then starts to come back up. So our number here is 1, 2. That's our vertex. Now the mirror of the y-intercept is just going to be where the y crosses, or where the parabola crosses the y-axis. It's going to be its look across, right? It's going to be its twin or reflection on the other side. So really all you have to do is look here and count the number of spaces to the axis of symmetry, and then go across and count the same number of spaces on the other side. So there's 1 space to the axis of symmetry. There's going to be 1 space to the mirrored y-intercept, to its reflection. And that is going to be where you would graph your parabola. So here, the easy way, not the easy way, that's the easy way, is just to look at it and count 1 space, 1 space. The mathematical way is to take the axis of symmetry, the x value of the vertex, and multiply it by 2. This times 2, so times 2 is the mirrored y-intercept x value. So that's going to be 2, and then it stays the same as the y-intercept for the y value, 3. And if you look, 1, 1, all right, so this is 2 on the x-axis and 3 on the y-axis, so 2, 3. So you can do it either way. You can look at it visually, which I highly recommend. You know, if you graph it out every time, then it's a lot easier to understand what you're doing. But this is what we're doing. We're making it to where we can graph a parabola by breaking it into its axis of symmetry, finding the y value of the vertex. All of those things are important. So that's what you should have there. And boom, those are all correct. Looks like I actually know what I'm doing for a change. Hallelujah, right? Okay, so we've got 4 more of these. So let's knock them out. We're not going to graph each one. And that's the point of doing it like this. It's going to be graded automatically by asking for the points. And then I know that drawing a graph on Jupyter is hard. It's not easy for everybody. So asking for the points is the same answer, but it can self-grade and you don't have to draw anything. So it's a win-win. All right, so we're going to complete the square here. So y is equal to negative x squared minus 4x minus 3. All right, right away, negative 3. So this is going to be 0, negative 3 for the y-intercept point. Now we can just go ahead and solve the rest of it. So I'm going to say y is equal to negative x squared minus 4x. Give myself a space, close the parenthesis, and put my negative 3 on the outside. I'm going to take the negative 4 divided by 2, that's negative 2, square that, and that equals a positive 4. So I'm going to add 4 here, subtract 4 here. So it's balanced. We're not adding anything to this side of the equation. We're just making it to where we can factor. So y is equal to, we're going to factor this. We put the x with this number here, x minus 2 squared, negative 3 minus 4, negative 7. Okay, so now this gives us our axis of symmetry. The opposite of this number is positive 2. So the axis of symmetry is positive 2. So we put that in here, positive 2. And the vertex is going to be the axis of symmetry plus this number. So the vertex is positive 2, negative 7. All right. 2, negative 7. And then the mirror of the y-intercept, if you don't graph it, remember what I said, you just double this number and take this as the y value. So that would be 4, negative 3. 4, negative 3. And we check that. And apparently I did something really, really bad. Okay. Let me look. Let me see what I got wrong. Because it's entirely possible. I do that sometimes. All right, so this is right. This is not right. Let me check my book. All right, I found my mistake. Right here, my negative sign. I did not do it. I just completely ignored it. So here's how we handle when it's negative. I didn't even pay any attention to it. When you have a negative sign on the x value, that means your parabola is going to open upside down, which is fine. But we cannot factor that. So what we're going to do is we're going to multiply everything by -1, and that's going to take the sign off so that we can factor it, and then we'll pass it back later. But right now we're going to use this process to pass the negative sign onto the y side. So we get negative y is equal to x squared plus 4x plus 3. And actually what I'm going to do is just move this over and go ahead and put this parenthesis right there. All right, that's what I forgot, and that's why it was not correct. So now I'm going to take this number, divide it by 2. That equals 2. I'm going to square that. That equals 4. So again, I'm going to add 4 and subtract 4 to keep this the same value. Then I'm going to factor, just like I did before. I've got x plus 2, because that's a positive 2, and that's a negative 1, because positive 3, negative 4, negative 1. That's x, yeah, this is squared, sorry. I'm looking for my exponent. Now, we cannot leave this a negative y, right? We want to solve for positive y. So again, we multiply everything by negative 1. We have y is equal to, we do not multiply the negative in here. We leave it on the outside. We leave this the same. We change the sign of this. All right. Now, y-intercept point stays the same because that is our original number. 0, negative 3. Now, the axis of symmetry is the opposite of this number, so that's going to be a negative 2. The vertex is negative 2, positive 1. And then our, all right, so our AOS, negative 2, vertex, going to be negative 2, positive 1. And then our mirror of y, I'm just going to call that MOY from this point on because my handwriting is awful. The mirror of y is going to be 2 times this for the x value. So 2 times that's going to be negative 4, negative 3. And that should all be right now. So you can see, you know, those negative signs, they'll get you if you forget that they're there. They do matter. Now they're all correct. Okay, I knew I had done the problem correctly, but I didn't because of the negative sign here. So pay attention, look for that negative sign. Whenever that happens, we have to hand it off to the y value to hold it until we can finish, because we can't factor it effectively with the negative sign. We just can't. Next problem. We only have 4 of these. Okay, very quickly. What is our y-intercept point? The x is always 0, and this is the y. Easy peasy. All right, now we've got to do the math. Y is equal to, there's no negative sign, woohoo! Makes life a little bit easier. I'm going to put that in parentheses, scooch, add 1. Negative 6 divided by 2 is equal to negative 3. Square that number, that's going to be 9. Now add 9, subtract 9. Y is equal to x minus 3 squared, because that's what we have here. And that's going to be a negative 8. That's as far as I need to go. So I can get everything I need from here. My AOS, my vertex, and my MOY, my mirror of the y. My AOS is going to be a positive 3 because it's the opposite of this number. My vertex is going to be 3 and negative 8. And my MOY is going to be 2 times this, so that's 6 and 1. So I'm going to put all of that in here. So I've got 3, and I've got 3, negative 8, and then I've got 6, 1. Let's check that, make sure that I haven't lost my mind. Okay, good. All right, we've got 3 more, including this one. So first point is 0, 4, because that one's easy. It's just this right here. All right, so let's complete the square. Y is equal to, we've got another negative, plus 4x plus 4. Let's get rid of the negative. So negative y is equal to x squared minus 4x minus 4. All right, so let me go ahead and do parenthesis and do that. All right, negative 4 divided by 2 equals negative 2 squared equals 4. Plus 4 minus 4. Negative y is equal to x minus 2 squared minus 8. Multiply everything by negative 1. Y is equal to the negative, or the opposite, of x minus 2 squared plus 8. So we need our AOS, our vertex, and our MOY. All right, the opposite of this number is a positive 2. The vertex is 2, 8, and the MOY is 4, negative 1. No, negative 4. Because I looked at that instead of this right here. Hang on. No, that's not right. Sorry. It's this doubled and then the original number, which is a positive 4. So that should be the right answer. All right, so we type those in. That's going to be 2, 2, 8, and 4, 4. That should be right. Yes. All right. 2 more. These go by pretty quick when you kind of get the hang of them. All right, so again, our y-intercept point is going to be whatever this number is, exactly the way it starts. So 0, negative 5 is the y-intercept point. Now we solve. Y is equal to negative x squared minus 4x minus 5. So we get rid of the negative. Negative y is equal to x squared plus 4x plus 5. Let's go ahead and move this guy out. Put in our parenthesis here. 4 divided by 2 equals 2 squared equals 4. Plus 4 minus 4. Negative y is equal to x plus 2 squared plus 1. Get rid of the negative y. So y is equal to the opposite of x plus 2 squared minus 1. So our AOS, vertex, and MOY. The axis of symmetry is the opposite of a positive 2, so it'd be a negative 2. Vertex is negative 2, negative 1. And the MOY is going to be 2 times this is negative 4. And the original number is a negative 5. So let's type those in. Negative 2, negative 2, comma, negative 1, and negative 4, comma, negative 5. That should be correct. Yep. Last one. Yay! All right. Y is equal to, all right, it's positive, so that's going to save us some time. The original point is going to be 0, 2. All right, we're going to complete the square. X squared plus 2x, leave a space, plus 2. 2 divided by 2 equals 1, squared equals 1. So plus 1 minus 1. Y is equal to x plus 1 squared plus 1. Okay, so the AOS, the vertex, and the MOY, that's negative 1, negative 1, positive 1, and negative 2, positive 2. So we'll type those in. So that's -1, -1, +1, and -2, 2. And that should be correct. And it is. All right, so that is lesson 99 to 100. It took us about 35 minutes to do both of those, all 11 of those problems. And they were not short problems, but we were able to do about 3 minutes per problem, even with me rambling and making mistakes throughout the whole thing. So there you go. If you know what you're doing, you can knock these out fairly quickly. So that's all I've got for now. I will do the next lesson for you, not tomorrow, obviously, because we have school, but I can work on those over the weekend and help you get caught up. I'll try to do as many as I can. If I can do 2 lessons tomorrow or on Friday, I'll try to do 2 on Friday and 2 on Saturday. That'll get you ahead 4 more lessons. So we're getting there. Just don't give up. Keep trying. Use Monday, Tuesday, Wednesday. You will not have any new lessons. You're done with lessons. New lessons being added to your list. So now you can start knocking them down without having anything added to your bucket, right? So let's just work on those. We'll do 2 a day on the days that we can, and we'll just knock them out, all right? I'm going to keep helping you. We're going to get you there. You're going to be fine, sweetheart. Don't stress about it too much. Just look at it as, quality video time with Miss Tracy. All right. I will see you tomorrow. Bye for now.